Okay. So third unit is protection of lines and feeders. So let me take this diagram. So if you take this diagram, you can see. Um, so this is a generator. So generator consists of so from the generating station. It is connected to the circuit, that is circuit breaker. From the circuit breaker, it is connected to the bus bar, and from the bus bar, this is nothing but it is feeders. So the feeders are connected here. It's having two feeders. Two feeders are having the two circuit breakers connected with each feeder. Then, as usual, you know what is differential protection. Therefore, CTs are connected here. So, and another one CT is also connected at the input side. So it is at the generator side where it gives the supply to the bus bar. So between these two, primary is connected with the primary and secondary is connected with the secondary, and a relay coil is connected here. As so first let us see what is the bus bar protection. So what is bus bar protection? So what is a bus bar? So bus bar is nothing but it is a place where generators as well as bus bar will be present at all the places. It will be at the generating station as well as at the substations. Everywhere bus bars will be there. So bus bars you will be having the at the generator side. If you take a power plant, you will be having 4 or 5 generators will be connected in the parallel in operation. So all these parallel, you know what is the condition for parallel operation of the alternators also. So now all these alternators will be connected to a common bus bar. So this similarly at the substation also. So with the help of the bus bars, so all from the bus bars only the feeders will be taken for the different connections to the distribution transformers, or it will be connected to the LT line, maybe LT line or maybe a HT line. Okay, so bus bars are present both at the generating side as well as at the distribution side. So both the areas it is possible. Mute the connections, sir. From it will be having the income. So in the definition, if you want to say bus bar is a generating stations or substations form different link between the incoming and outgoing circuits. So if a fault occurs on a bus bar, what happens? So it will disturb both the generating side as well as at the distribution side. So both the sides you will be having the problem. So bus bar for the purpose of production, isolating switches, circuit breakers, and associated. You will be having the switches, circuit breakers, association. You will be having all the connections. You will be having. So most probably, what is the production which is applied for the bus bar is differential protection and default bus protection. So first thing which we are going to see is differential protection. So first, a differential protection, you know already at the transformer side and transformers and alternators at the alternators. So both the sides you will be studied what is the differential connection. So basically what is a differential connection is. So basically what is differential connection is. So if there is a difference in the secondary side, when if you'll be having the CTs at the input side or at the CTs at the other side. So at the both the sides, at any one side, if there is a difference in the current, that current will be flowing in the secondary side of the CT, and the secondary current will operate the relay circuit, so that relay circuit will operate the circuit breaker. This is what you have studied at the production of alternators as well as at the transformers. The same thing is applied here. So here a single phase circuit is given. So where the generator single line diagram is given. So here it is generator. From the generator, it is connected to the CT, and from the CT, it is connected to the circuit breaker. And I have already explained the circuit. Okay. So what happens here is, so if there is any difference in the feeders, if any one of the feeder is having a problem, or if there is an over voltage or any problem occurs, what happens is these circuit breakers will sense the fault current, and there will be some difference in the current will be flowing, which will be sensed by the relay, and this relay will be operating the circuit breaker. So what is differential protection is? The basic method for bus bar protection is the difference scheme in which currents entering and leaving the buses are totalized. So during the normal load condition, some of the currents will be equal. So at the time, this relay circuit will not be operating, and the trip circuit will not be operated. So when the fault occurs, the fault current upsets the balance, it gets unbalanced, and the differential current will be operating the relay. So this is the remaining points were explained regarding the connection, how it is given the connection and how it works. So difference of the current will flow through the relay, and the opening of the either it is connected with the generator. So transmission line will be having a generator, circuit breaker, lines, everything you will be having at the each transmission lines and feeders, everything will be there. So what are the circuit breakers which is connected where you are sensing the fault? This relay will be operating and it will be disconnected. Okay. So next is fault bus protection. So it is possible to design a substation so that fault that develop are mostly the fault which occurs in the substations are earth faults. So this can be, so before I'm explaining, just to show you the diagram, how it will be there. So if you see this diagram, you can see the diagram here. So this is here, this generating side, the same circuit diagram, same diagram, but here the generators of these things are avoided. So only one main line, this is bus bar continuity is taken here. Here one circuit breaker is connected. The circuit breaker is connected with the relay circuit. The relay circuit will be operating the troop circuit. So here it is having the two feeders as usual, like a previous diagram. But you can see here, yes, supporting structure which is called as a fault bus, which is connected along the lines which forms the closed path across the transmission line. So between the line and between this fault bus structure, an insulator is connected. So, and if there is a fault current that will be sensed by this fault bus, and this fault bus will be operating the circuit CT, and the CT will be operating the relay circuit. So this structure is called as the metal supporting structure, or it is also called as the fault bus, which is earthed to a current transformer. So which is earthed through a current transformer. Here a relay is connected across the secondary of the CT, involving the connection between the conductor and the earth. The operation of relay will trip the breaker. This is common thing. Next, production of lines. The probability of fault occurring on the lines is much more due to their greater length and exposure to the atmospheric conditions. So already you have studied regarding the, I think you don't have much knowledge on the power quality. So basically at transmission systems, you would have studied. Most of the faults occurs because we don't have any underground connection. We are having only the overhead connection. So on this overhead connection also, which is flowing for a long distance. So when it flows through a long distance, it will be facing the many problems like, for example, if you take a lightning, already I've studied the topic called as lightning. So we'll be having what are the causes, how the strokes will have, what are the problems, what are the faults which is created by the lightning or studied. So like that, many issues are there. Maybe short circuit conditions will occur. Some many breaking of the circuits, transmission lines may occur, or if any lightning may occur. So all these things which creates a problem. So since our transmission line is exposed to the greater length and atmospheric conditions, already you have studied about in transmission and distribution, I think you studied about the coronal losses and all these losses. So all these losses are nothing but due to the atmospheric conditions. At the wet conditions like northern India, you can where more amount of snowfall is there. So when the snow gets deposited on the transmission lines, you will be having more amount of fault, coronal losses will be there. And in the high transmission lines, so if you are not maintaining the proper distance between the transmission lines, you will be having the problem. So like this, many issues are there. Sag, swell. So already I told you what is swell, and swell is a problem. Surge. Surge is the problem which occurs due to the lightning, which is a sudden increase in the voltage. So see, these like many problems will be happening in the transmission lines. So we need to give a proper protection against these transmission lines. So what are the recommends, what is the need for the line protection is in the event, so these are the points which are given. So in the event a short circuit breaker closest to the fault should open fastly. So this is nothing but this is primary protection and backup protection. You already know what is primary protection and what is backup protection. So primary protection means, for example, you can take the same circuit diagram you can take. So for example, if you are having the two feeders that you are having. So in this feeder, if you're having one circuit breaker, let us go for the previous diagram. So here you are having one circuit breaker, and here you are having the circuit breaker. First, initially the circuit breaker must be connected to a relay. So when a fault occurs at the feeder 1, this circuit breaker must be opened and the relay must be operated. Or if a fault occurs at the 2, other circuit breaker has open. If these two are not functioning properly, this circuit breaker has to be open. So this side is called as primary production and this side is called as the backup production. Okay, so that is what here they have explained. So in the event of short circuit, the circuit breaker closest to the fault should open and all other circuit breakers remaining in the closed position. Others should be operated. So in the case nearest breaker to the fault fails to open, next backup production will be operated. The relay operating time should be, so another thing is same thing. So here this feeder, for example, in this feeder side, if it's circuit breaker, if it is 2 seconds for operating, so this will be, sorry, 2 seconds for operating. You can take this circuit breaker with a time of 3 seconds. So until 2 seconds, the circuit breaker will be waiting, and if it doesn't operate and if it doesn't clear the fault, this circuit breaker will be operating. Okay, so time duration is must be less when compared to that of the circuit breaker. So that is what the third point they have given here. The relay operating time should be just as short as possible in order to preserve system stability without unnecessary tripping of the circuits. So here the production of line presents a problem quite different from the production of station apparatus, generator, transformers, and bus bars. So these are located at a particular place. For example, you know what are the productive devices which we can use for the transformer productions like Buchan's relay. So if a fault occurs, if it is short circuit, or if there is a fault occurs in the transformers, this will be easily sensed with the help of the some productive devices like Buchan's relay and all those things. So generator, transformers, bus bars, these are all located at a particular location. But in the case of transmission lines, it will be somewhere at the highest inside the forest. It will be there inside the farmlands will be there. So people cannot go and continuously monitor over a long distance. That is a problem. Okay. So while the differential production is an ideal method for the lines, so input side we can connect on CT, you know, a secondary side, that is output side you can connect on CT, so that you can have a difference in a voltage and easy to predict. So while differential production is ideal for the transmission lines, it must be more expensive, but it is expensive because it has to be connected over a long distance. So because the rating of the transmission line is also high, HT lines. So two ends of line may be several kilometers, that's what, several kilometers, and it compass the two currents, and it's costly. So it is very difficult to implement this. So expensive may be justified, but in general less costly methods. There are some less costly methods out there. So these are some three less costly methods. The first one is time delay overcurrent production. Second is differential production, and third one is distance production. So you know what is distance production, more away, all these things which you have studied at the production and alternatives. So same thing here, it will be repeated, but in the case of transmission lines, how we are implementing. So this is time dated overcurrent production. You can see here. So in this scheme, you can see, and so and here the plot is made between the operating time and the distance. This operating time is nothing but operating time of a relay. Okay, so distance is how many kilometers. So you can example, you can take it as, for example, one generating station is located, and